You and your team have entered DARPA's FANG Challenge. Your goal is to design a next-generation amphibious infantry fighting vehicle for the U.S. Marine Corps. In Challenge Number 1, you are tasked with designing a drivetrain and mobility system for your FANG vehicle. For you to beat the competition and win your share of the $1 million prize, your team's design must meet all the key vehicle mobility requirements and score higher than the competition according to DARPA's objective scoring system. For Challenge 1, DARPA has identified over 150 specific requirements that must be addressed by each FANG vehicle's mobility and drivetrain design. A detailed breakdown of these requirements is provided in the Mobility Drivetrain Design and Functional Requirements document. It can be found in the Requirements area on the vehicleforge.org website. The mobility drivetrain requirements are grouped into 5 main vehicle subsystem attribute categories: automotive performance, transportability, environment, programmatic requirements, and configuration requirements. Within the design requirements for the FANG challenges are a set of top priority items known as Key Performance Parameters. KPPs are essential performance attributes that are critical to the vehicle's operational capability and must be met for any design to be successful. Each requirement is defined by a minimum desired threshold value and an ideal goal objective value. Scoring is based on exceeding the threshold and getting as close to the objective as possible for each requirement metric. Failure to meet a minimum threshold value for a KPP will result in a score of 0 and result in the design being eliminated from the competition for non-compliance. Maximize your score by hitting the objective. Exceeding the objective is acceptable, but it does not further increase your score. These requirements will be assessed through 2 processes. The first, called test benches. Place your design in a relevant environment for simulations that predict the performance of your design. The second process is through participant self-certification of adherence to the design guidelines. These self-certifications serve as a checklist to ensure all essential design elements are included and will be evaluated by DARPA judges. So what are test benches? They are design verification tools specifically built for the FANG challenge that use physics-based simulation to predict system performance based on component attributes and interactions. Test benches also recognize when the operational limits of any of your system's components are exceeded. For example, if an incline test bench analysis finds that the torque limit of your drive shaft is exceeded during an uphill climb, your design score will reflect a failed design. DARPA will provide teams with a component model of a surrogate hull that must be used as the standard interface for each competing drivetrain mobility design. The hull will be semi-parametric, which means that designers will have some flexibility with its size and shape. To test the viability of the vehicle resulting from the combination of the surrogate hull and your drivetrain mobility system, you will be provided with simplified model representations of personnel. They must be located within the surrogate hull during test bench runs to accurately predict performance. About 2 months into the competition, the 20 highest scoring teams will be selected to continue into the final round of design and testing. In this phase, scoring criteria will be more comprehensive and additional performance requirements will be introduced. Use the detailed feedback to optimize your design and win the FANG Challenge.